This is the Bits&Bits SF525. It's a 1/2 inch shank, 2.5 inch diameter surfacing bit. It features 2 replaceable Astra-coated carbide inserts, each with 4 cutting edges. The Astra coating reduces friction and heat buildup, which prolongs the life of the cutting edge, and it has a max RPM of 14,500. Also available is a replacement set of carbide inserts. The ability to rotate and change carbide inserts on a bit like this results in a much lower long-term usage cost, as the more you use it, the cheaper it gets. Today I'll be testing the bit to see how it performs. The machine I'll be using is an Avid CNC with NEMA 34 motors and a 6.5 kilowatt spindle. However, I'm powering the machine on single-phase 240 volt, so the power output is roughly 4.7 kilowatt. Testing will start on a slab of hickory. I frequently use a bit similar in profile to this one, so I have a good idea of where to start. The baseline specs are an RPM of 14,500, a 0.1 inch depth of cut, 66% step over, which is about 1.65 inches, and 300 inches per minute of travel. I want to force a conventional cut with every pass, so I made a series of lines in V-carve that are offset by the step over distance of 1.65 inches. I also want each pass to be a different speed, so I made a separate toolpath for each line. Starting with a travel speed of 225 inches per minute and increasing by 15 inches per minute with each line to the left, this puts our baseline speed of 300 inches per minute near the middle. It allows some conservative cuts to the right and faster cuts to the left. I let the program run, and to my surprise, there was no struggle to the cut whatsoever. Each of the passes sounded the same, and I couldn't tell the difference between any of them. The final pass, or the one all the way to the left, had a speed of 390 inches per minute, but it did not count as the cutting path was mostly on air, which means the fastest full step over pass, or the 66% step over, was at 375 inches per minute with no problems. In an effort to push the bit a little harder, I lowered the bit and started the program over, but this time with a feed rate multiplier of 125% in Mach 4. This will multiply the speed by 1.25 for all of the cuts. The same program is run once again, and just like before, I cannot visually or audibly hear the machine struggle at all. Every pass sounded good. On this run, the final full step over pass was 390 inches per minute times the multiplier of 1.25 for an actual travel speed of 487.5 inches per minute. That is impressive. The surface finish on the hickory was good enough to give a slight low angle reflection, but not good enough to go straight to finish. Sanding is definitely required when cutting at these speeds, which is expected. Here you can see the depth per pass of 0.1 inch. Some will argue that a more aggressive cut can be taken by slowing down and taking a deeper bite, but that's not how I prefer to use surfacing bits. Just like a planer, I prefer to take a shallow cut to reduce the amount of stress released into the slab, or out of the slab I should say. I flatten a lot of large tabletops, and the goal is almost always to leave as much thickness as possible. I'd always prefer to take 2 0.1 inch passes over a single 0.2 inch pass. The next test isn't really a stress test by any means, as I knew it wouldn't be a challenge. Surfacing my MDF spoil board at 500 inches per minute. Now we're getting into the realm of the machine being the limiting factor versus the bit, as my machine's cut speed is limited to 500 inches per minute. One final test I wanted to do was to see how it would handle a delicate trim. This is an end grain cutting board with various species of hardwood, and it's held to the table just with perimeter stops and gravity, no top-down holding. The goal here is to see if the bit wants to grab or lift the material, like an upcut spiral bit, and to see if any burning results from a slower speed and a more shallow cut. For small odd jobs like this, I typically do not run a program. Instead, I set the jog rate, the depth, and the spindle speed manually in Mach 4. Because these jobs are so small, it's basically faster to manually jog the machine than it is to actually create a program and then let it run. Manually traversing from back to front and left to right results in all conventional cuts. This is a situation where I wouldn't want to go really fast because too much lateral force on the cut may grab and try to pull the piece up due to its light weight and the lack of top-down work holding. No grabbing here though. It slices right through the end grain fibers without any sign of lifting, and the combination of a slower feed rate and shallow cut did not burn at all. Here's my final thoughts. I didn't go crazy with these tests, but I did prove a few things. First, I think the limiting factor for my setup was the machine X and Y travel speeds maxing out at 500 inches per minute, and not the actual bit, which sounds kind of crazy to say. The max speed I tested on the Hickory was 487 inches per minute, but with no visual or audio indications of stress. I'm confident I could have flattened the slab at 500 inches per minute. That's the top cutting speed of my machine, so I'm a little hesitant to keep the machine maxed out for a full stress cut like that. Again, with large cuts like tabletops and slabs, I prefer to cut no deeper than 0.1 inch per pass. Cutting deeper will require the travel speed to slow down, but I prefer to cut a little more shallow on large slabs and tabletops to reduce the impact of stress relief and also to prevent accidentally removing more material than necessary. With all that said, here are my recommended feeds and speeds. These are the numbers that I saved in my VCarve tool library and the starting point for all of my surfacing cuts. If I'm cutting something harder than hickory, which is something like Osage orange, not very common at all, or if the first pass in my cut program is a full width pass and not a 66% step over pass, I'll likely bump the multiplier in Mach 4 down to 75% and adjust based upon visual and audio feedback. If you are interested in purchasing this bit, you can do so at Bits&Bits.com. Use my coupon code JBates to save 10% at checkout. That's a non-affiliate code, by the way. It's just the best savings that I can pass along to all of you out there. Take care and have a great day.